Have you ever wondered what the universe is truly made of? I mean made of.
Physics as we know it, the physics of planets and apples falling from trees, breaks down when we enter the strange world of quantum mechanics.
Imagine shrinking down, smaller than a speck of dust, until you reach a realm where the very fabric of reality shimmers and dances. In this bizarre landscape, particles can be in multiple places at once. They can even be connected across vast distances, their fates intertwined in ways that would make Einstein himself scratch his head.
In this video, we'll dive into the most intriguing theories of quantum physics that challenge our understanding of reality. Buckle up, because things are about to get weird. Let's start with one of the most mind-bending concepts in quantum mechanics, superposition. Imagine a single particle, like an electron, not as a tiny billiard ball, but as a shimmering wave of possibility. This wave exists in multiple states at the same time, occupying different energy levels, spinning in opposite directions, even being in different places simultaneously.
It's like that old saying, a watched pot never boils. Except in this case, it's more like an unobserved particle is doing everything at once.
The act of observing a quantum system forces it to choose a state. It's like the universe is playing a cosmic game of hide and seek, and when we peek around the corner, everything snaps into a single definite position. Buckle up, because we're diving into one of the most mind-boggling concepts in the quantum universe: entanglement. Imagine two particles, born from the same quantum event, linked in a way that transcends space and time. They're like a cosmic pair of dice, separated by light years, yet forever connected.
Roll one die and it lands on 6. You instantly know the other die, no matter how far away, will also show 6.
Scientists have entangled particles in the lab and observed this spooky action at a distance. They've sent entangled photons to opposite ends of the Earth, showing that measuring one instantly determines the state of the other. Imagine quantum computers solving problems in seconds that would take classical computers billions of years. So far we've explored the bizarre world of superposition and entanglement. Now let's dive into another fundamental principle of quantum mechanics that will truly make your head spin: the uncertainty principle.
This principle, formulated by Werner Heisenberg, states that there are certain pairs of properties of particles, like their position and momentum, that we can never know with perfect accuracy at the same time.
Think of it like this. Imagine trying to pinpoint the exact location and speed of a buzzing fly. The more you focus on determining its position, the blurrier its motion becomes.
In the quantum world, this uncertainty isn't just a limitation of our observations, it's an intrinsic property of the particles themselves.
It means that the universe is not a deterministic clockwork, but a realm of inherent randomness and unpredictability.
The uncertainty principle has had a profound impact on technology, from transistors to medical imaging devices.
So the next time you use your smartphone or watch a movie on your computer, remember the uncertainty principle.
Hold on to your hats, folks, because we're about to delve into one of the most mind-bending aspects of quantum mechanics: wave function collapse.
When we make a measurement of a quantum system, its wave function collapses.
This raises a truly mind-boggling question. Does consciousness play a role in shaping reality?
This is known as the measurement problem, and it's one of the biggest unsolved mysteries in quantum mechanics.
Some physicists believe that consciousness is a fundamental aspect of reality, just as fundamental as space, time, and matter.
Regardless of your stance on this issue, there's no denying that the wave function collapse is one of the most bizarre and counterintuitive aspects of quantum mechanics.
So the next time you look up at the stars, remember that you're not just passively observing the universe, you're actively participating in shaping it.
Get ready to have your mind blown wide open, because we're about to explore one of the most mind-boggling interpretations of quantum mechanics: the many worlds interpretation.
This theory, proposed by physicist Hugh Everett III, suggests that every quantum measurement branches into a separate, parallel universe.
Imagine this. You're faced with a choice, like whether to order pizza or sushi for dinner. In the many worlds interpretation, both choices actually happen, but in different universes.
These parallel universes are completely separate and non-interacting.
Even though we can't directly observe these other universes, the many worlds interpretation offers an elegant explanation for quantum mechanics.
Instead of a single universe, The many worlds interpretation proposes a multiverse where all possible states are realized. The possibilities are literally endless.
Alright folks, get ready for another mind-bending concept that lies at the heart of quantum weirdness, wave-particle duality.
Think of it like this. Imagine a beam of light shining through two narrow slits. Now, if light were just a stream of particles, you'd expect to see two bright spots on a screen behind the slits, right? But that's not what happens.
Instead, you see an interference pattern, a series of bright and dark bands, as if the light were interfering with itself, like waves overlapping in a pond.
But here's the really weird part. If you try to observe which slit each photon goes through, the interference pattern disappears.
This wave-particle duality is one of the most fundamental and perplexing aspects of quantum mechanics.
This concept has had a profound impact on our understanding of the universe, leading to the development of technologies like electron microscopes.
So, the next time you turn on a light switch or take a picture with your smartphone, remember the wave-particle duality.
Hold on to your hats, folks, because we're about to explore one of the most mind-boggling concepts in all of physics: vacuum energy and quantum fluctuations.
Now you might think that empty space, a true vacuum, is completely empty, devoid of any matter or energy.
But according to quantum mechanics, even the emptiest of spaces is teeming with activity.
Imagine a still pond on a calm day. Now, zoom in really close, and you'll start to see tiny ripples and fluctuations on the surface of the water.
These fluctuations, known as quantum fluctuations, can briefly create pairs of particles and antiparticles, which then annihilate each other in a shower of energy.
These particles, which pop in and out of existence, are called virtual particles, and they're not just some theoretical construct. They have real, measurable effects.
So the next time you look up at the night sky, remember that the vast expanse of space is not empty, it's a seething cauldron of quantum activity. Get ready to enter a world where the impossible becomes possible, because we're about to explore the mind-bending phenomenon of quantum tunneling. Imagine rolling a ball up a hill. Classically, if the ball doesn't have enough energy to reach the top, it will simply roll back down. But in the quantum world, there's a chance that the ball could tunnel through the hill, appearing on the other side as if by magic.
This isn't just some theoretical mumbo-jumbo. Quantum tunneling is a very real phenomenon that has been experimentally verified countless times.
It's the reason why the sun shines, allowing protons to overcome the electrostatic repulsion of the strong nuclear force and fuse together, releasing tremendous amounts of energy.
Quantum tunneling also plays a crucial role in many everyday technologies like transistors.
So, the next time you use your smartphone or watch a movie on your computer, remember the mind-bending phenomenon of quantum tunneling.
It's a reminder that the universe is full of surprises and that the impossible is often just a matter of perspective.
We've explored a lot of mind-bending concepts in this journey through the quantum realm superposition, entanglement, wave-particle duality. But you might be wondering, if the quantum world is so strange and counterintuitive, why don't we see these effects in our everyday lives?
The answer lies in a phenomenon known as quantum decoherence.
Quantum systems are constantly interacting with their environment, bumping into air molecules, absorbing and emitting photons, and generally getting entangled with everything around them. This constant interaction disrupts the delicate quantum coherence, causing the system to lose its quantum weirdness and behave more like a classical, predictable object.
Think of it like this. Imagine a perfectly still pond reflecting the world around it like a mirror. Now toss a pebble into the pond and the reflection is shattered, replaced by a chaotic jumble of ripples.
Quantum decoherence is the reason why we don't see macroscopic objects like cats and coffee mugs existing in multiple states at once. It's also the reason why building large-scale quantum computers is so challenging.
So, while the quantum world may seem strange and counterintuitive, it's important to remember that it's always there, lurking beneath the surface of our everyday reality.
Fasten your seatbelts, folks, because we're about to embark on the most mind-bending leg of our quantum journey yet, quantum field theory. This theory combines quantum mechanics with special relativity to understand the universe's fundamental forces.
Particles are seen as excitations or vibrations in underlying fields that permeate space and time.
These fields are everywhere, even in the emptiest of vacuums.
Like ripples on a pond, particles are disturbances in these fields.
These fields carry energy and momentum, interacting to create the forces we observe.
In the grand cosmic tapestry, Particles are notes played on the symphony of quantum fields.
The mysteries of quantum physics challenge everything we think we know about the universe. From particles existing in multiple states at once to the possibility of parallel universes, the quantum realm is a strange and wondrous place.
It's a realm where the very act of observation can influence reality, where particles can be in two places at once, and where the impossible becomes possible.
Quantum mechanics is one of the most successful scientific theories ever devised. It has led to countless technological advances, from lasers and transistors to medical imaging and nuclear energy.
As we continue to probe the depths of the quantum realm, who knows what other wonders we might uncover?
So keep exploring, keep questioning, and keep your mind open to the infinite possibilities of the quantum universe.